Hello everyone, welcome back. In this video, I am going to talk all about this chapter number system from your HSTR and KREIS syllabus. This video will be useful for TET, Karnataka TET and Kendriya Vidyalaya aspirants as well. Now this is your HSTR syllabus for science teacher. The maths syllabus, it contains around 24 chapters. This number system is the first chapter. So in this lecture, let us discuss all about this chapter and let's also solve all the expected questions from this chapter. Now here I have zoomed your syllabus. The number system, it contains a place value, expanded form, basic operation, simplification and all sort of numbers, then square and cube numbers and their roots, then of course playing with numbers and HCF and LCM. Firstly, let's talk about expanded form of a number. In standard form, see for example, if I am giving you a number 7294. This as it is, if you are writing 7294, this will be your standard form. If you try to expand this number, how will you expand? You will try to write this number by showing the value of each digit. Here 7 is in thousands place, right? So you write 7000. Then 2 is in hundreds place, 9 is in tens place and 4 is in ones or units place. So this is how you can expand. Now another example is see, you have one number with a decimal point 317.29. Now how can you expand this number? This number, see the whole number 317 you expand as it is. Here 3 is in place of 100, 1 is in place of 10 and 7 is in place of 1. That you expand. But then again for decimal point, you go in the opposite direction. Here you write 0.2 for 2. And you write 0.09 for 9. Okay. This is how you expand a decimal number. So basically, when you expand a number, you write its place value in that place. See for example, here if it is 2385, you have 1000 along with 2, you have 100 along with 3, you have 10 along with 8 and you have 1 along with 5. Okay. See, using this expanded form, we have done this numerical. This question is from your 2015 HSTR exam. I have done all the questions I have solved from 2015 HSTR question paper. I will give you the link in the description. You can click the link and you can watch that lecture. Okay, here I am not going to explain how I have solved. I am just giving you an idea that this question came from that topic, the expanded form. And using this expansions only, we arrived at the final answer for this question. Okay. We were talking about the place value. The place value of a number means, as I told you, the address of the number. See for example, if I am giving you 5468. Here the place value of 8 is ones, 6 is tens, 4 is hundreds and 5 is thousands. Now you can easily expand keeping this in mind, right? You write 5 into 1000 plus 4 into 100 plus 6 into 10 plus 8 into 1. So whatever is the address of that number, no, that you call as place value of that number. Now let's talk about the basic operations. See, this is very simple actually. We all know. But just my motto is that we can just throw a light little bit and we can recall many things which we already know. Okay. Just I don't want to skip topics. Just have a glance and then we can move on. So what are basic operations of arithmetic? They are addition, subtraction, multiplication and division. When you do addition, those two numbers which you add, that you call them as addends. And the answer which you get after addition, you call it as sum. So other name for addition is sum. And then in subtraction, the other name for subtraction is difference. The two numbers which you subtract from each other, those numbers, in that first number you call as minuend and the second number you call as subtrahend. And the answer will be your difference. Then in multiplication, if you are multiplying for example 8 and 4, your answer will be 32. That answer is known as product. And those two numbers which you are multiplying, they are factors of this 32. Okay. And then coming to division. In division, what all you do? While you divide, for example, you are dividing 8 by 4. This 4 will become your divisor, 8 will become your dividend and your answer will become quotient. And if any other number is remaining while you do this division, that remaining number is known as remainder. Okay. Here in this case it is 0, so remainder will be 0. Now we all know basic operations. For sure we all know. But one thing we must have forgotten is what we call as BODMAS. BODMAS, it is one procedure which we always follow for any basic operation in mathematics. Okay, see for example, if in one number addition, subtraction, multiplication, division, everything is there in that problem only, then how you solve? You have to follow certain steps to solve. You cannot simply solve like that only. You cannot first do whatever you feel, then you will get the wrong answer. If you follow this procedure of BODMAS, then only your answer will be correct. Now what is this BODMAS? The full form for BODMAS is brackets, other, division, multiplication, addition, subtraction. Basically, this BODMAS, it tells you the order in which these operations should be done. First you remove the brackets, then you remove the other things from the sum like this squaring and indices and all that. After that you divide or you multiply. At last then you either, if you needed, you add, or if needed, subtract. Okay, you can use this BODMAS when it is not clear for you what to do next, because you do whatever you feel, then your answer will be wrong. Okay, so this is the procedure for mathematical operations to be carried out. For example, if a question is like this, find the reciprocal of square root of 4 plus 6 into within brackets 12 minus 2. Here what you do? First you remove the brackets. To remove the brackets, what you have to do? You have to do the operation between 12 and 2. It is subtraction. 12 minus 2 is 10. Now you write 10 and remove the brackets. Next, according to BODMAS, what you have to do here? Division is not there. Other things are also not there. Third, fourth will be multiplication. Now you multiply. Where is the multiplication here? Multiplication is between 6 and 10. So 6 tens will become 60. That you write. Again, next is addition. 60 plus 4, 64. Then no subtraction is there, right? If subtraction was there, we would have done subtraction here. Then again, square root. Just you remove the square root and that will be your answer 8. Now you have to find the reciprocal, right? So the reciprocal will be 1 upon 8. Okay. Another example I will give. See, for example, you have this type of a sum. 4 into within brackets 10 plus 15 divided by 5 into 4 minus 2 into 2. What you do according to BODMAS? First remove the brackets. For that removal of brackets, what you can do? Here in this case, for the removal of brackets, you have to do the mathematical operations inside. That's why leave that step. Again go to the next step, that is division. See if there is division anywhere. Yes, it is there. It is 15 divided by 5. It will be 3. Then again next step, multiplication. It is there. Yes, it is there. It is there in 2 places. 3 4s are 12 and 2 2s are 4. Then you write it down. Again, then next step will be addition. Then subtraction will come. Then you can remove the brackets and that will be your answer after you multiply. Okay. So this is how you can use BODMAS. See, I am giving you examples. You just take a pen and a paper and try to solve it by yourself. Don't think that this is a school maths. I am telling you, many times we make silly mistakes in mathematics, and I am sure that many times that silly mistakes will be from school mathematics only, especially our primary and high school mathematics. So we will not take any topic lightly. Okay. Now they can ask you a question like this in your HSTR exam, or even in KREIS they can ask you a question like this. ABCD is a 5-digit number. When multiplied by 13, it gives a number purely formed by the digit 9. Then the value of A plus B plus C plus D plus E is, they have given you 4 options. They have given that there are 5-digit number. When it is multiplied by 13, it will give you a one number. That number only has digit 9s. It does not have any other digit 9s. This is what they have given. Now you have to find the value of the digits A plus B plus C plus D plus E. Okay, this type of sum we did in HSTR old question paper 2015 also. If you watch that video, you will come to know. Now because they are telling that there is a 5-digit number and it consists of only 9, we will write 999s. But then if you multiply it with 13 means how many digit numbers will be there? It will be 6, right? If you multiply a 5-digit number by a 2-digit number, you will get 6-digit number. So you write 6 digits here. Those 6 digits all should be 9. Then you divide it by 13. When you divide it by 13, you will get some quotient. Here in this case, this is like an assignment for you. You take pen and a paper, you try to divide it. That's the reason I am not using a pen here. Because this is a simple chapter, right? I want you all to work out. I am giving you the direction. I am guiding you how to do sums. But you have to do by yourself. Okay. Now you divide this 999999, the 6 times 9 digit number, divided by 13, you will get one number. This number is your ABCDE. Now add these A, B, C, D, E individually, you get 27. So option B, 27 will be the right answer. Okay, let's move on. Let's talk about natural numbers, whole numbers and integers. See, natural numbers, whole numbers and integers, they all look the same, but they are not same. Natural numbers means just 1, 2, 3, 4, 5, 6. These numbers are natural numbers. This, if you add 0 in this natural numbers, that means if you write 0, 1, 2, 3, 4, then those group of numbers will become whole numbers. So remember, in natural numbers, there will not be 0. But whole numbers, they will include 0. Now integers, it will include all these natural numbers and whole numbers. How? See, you are having this minus sign numbers also, isn't it? You will have negative sign numbers, you will have 0, you will have positive sign numbers. All this together will become integers. This you have to know the difference between natural numbers, whole numbers and integers. Now one more very important type of numbers are rational numbers. When you talk about rational numbers, you are always talking about fractions. Okay? Most numbers you talk about or you deal with, they are all rational numbers. See, we told you about integers, right? Integers, they can be negative numbers, they can be positive numbers, even 0 will be an integer. But in fractions or rational numbers, you write any number in the form of a fraction, right? That means P by Q, right? Here, only one condition is that your denominator, the Q, it will be a non-zero integer. Because if it will be 0, then your fraction will become infinity. Anything divided by 0 will become infinity. That's why in rational numbers, if the fractions are written, they are written in the form P by Q and Q will not be equal to 0. Okay? There can be a negative sign in the fraction, there can be a positive sign in the fraction. And then these fractions, sometimes if you divide them, you will get their recurring decimals. Usually if you divide a fraction, you will get a decimal. But sometimes you get recurring decimals. Recurring decimals means, see for example here, if I divide 1 by 3, you get 0.333333. That 333 is repeating only every time. So this type of a decimal is known as a recurring decimal or a terminating decimal. Now numbers can be divided into two types of numbers, prime numbers and composite numbers. All the numbers which we deal with, they can be either prime numbers or composite numbers. Prime numbers means they are those numbers which are positive, but they don't have factors besides themselves. That means a prime number, it is that number which will not divide by anything. For example, 2, 3, 5, 7, 11, 13, 17, 19, 23. These numbers, they don't come in any table, right? Except their table. That means 2 ones will be 2, 3 ones will be 3, 5 ones will be 5, 7 ones will be 7. Except themselves, they will not be found in any other table. Such numbers are known as prime numbers. Other than prime numbers, whatever the numbers are remaining, they are known as composite numbers. That means they will be occurring in your table. In any of the table, they will be occurring. That means they will have factors besides itself and unity. They will have other factors also. Okay. Now let's know what is this word factorial. Factorial means for any natural number, you write factorial as, see, if that natural number is n, you write n factorial. Factorial means you write this exclamatory symbol beside n. Okay. Then you go on writing the numbers and multiply them. 1, 2, 3, 4, 5, 6 till n. See, for example, if you have 3 factorial, you write 1 into 2 into 3. If you have 5 factorial, you write 1 into 2 into 3 into 4 into 5. Then you multiply all those. That answer will be your value of that factorial. Okay. And note that 0 factorial is 1. This you should remember. Now this question came in HSTR 2015 question paper. We have solved it. I hope you all remember. The question was that P by Q is there. It is given in one form, that is rational form. This is equal to 1.99. Then we have to find X. What we did, we multiplied both sides by 10 because the decimal point, it was only after one number. So we multiplied by 10. Then again we found the value of X. So this type of a question they may ask based on rational numbers. Now let's see what are multiples, factors and prime factors. First, multiples. Multiples means, see, any number, it will come in a table. That is a multiple. For example, if you are talking about first 8 multiples of 13. What you do, you write 13 table. 13 ones are 13, 13 twos are 26, 13 threes are 39, 13 fours are 52. You write till 8. So whatever answers you are getting in table of 13 till 8, those numbers will be the first 8 multiples of 13. Okay. Now factors. Factors means the numbers that is divided into it. Divided into it means, see for example, if I want to find the factors for 24, what I do, I should start from 1 and I should go on writing the numbers wherein you can get 24. First is 1 into 24 will be 24. Next, after 1 you will get 2. 2. In 2 table you will get 24 where 2 12s are 24. Next is 3. In 3 table where you will get 24, 3 8s are 24. Next is 4 where you will get 24 in 4 table, 4 into 6. Next is 5. In 5 table you will not get 24, right? Then you skip it. Then go for the next number 6. In 6 table you will get 24. Yes, you will get in 6 4s are 24. So these all numbers 1, 2, 3, 4, 6 and then in the right hand side 24, 12, 8, 6, all those numbers, no, which are repeating, you can remove those numbers. Which are not repeating, you keep them. So these all will become factors of 24. Okay. Now in multiples, we can have a least common multiple. What is the least common multiple? It is the smallest number that will divide by all the numbers which are given. For example, if you have to find the least common multiple or LCM of 18 and 32, you write this L and then you start dividing, right? You first see that it's a even number. So you start with 2 because 2 is a even number. If it was a odd number, then you should have started with 3. Okay. You start with 2. Go on and wherever you get a odd number, then again you start with 3. Go on dividing. You divide till you get 1. After that, whatever are the multiples here, you multiply them. 2 into 3 into 3. So this will give you least common multiple. Okay. In the same manner, this was for multiples, right? In the same manner, we have for factors, that is known as highest common factor. It is the biggest number that will divide into all the numbers in the question. How do you calculate this HCF? For example, if you want to calculate the HCF for 180 and 84, what you do? 180, you do LCM and you write the numbers here. What all numbers if you multiply, you get 180. You write that. Again for 84, what all numbers you multiply, you start from 2 always. What after 2 you go for 3. Do LCM here also. Then you write the two numbers separately and then write down their factors. Then you see what all factors are common. Here 2, 2, 2, 2, 3, 3. These much are common, right? In both in 180 and 84. 3 and 5 and 7 they are not common. So leave them. Whatever are common, you take them and multiply. This will give you highest common factor. Okay. See, I am giving you direction. I am guiding you. You should take book and pen and do it yourself. Pause the video right now. Then you do it yourself. You find the LCM of 18 and 32 by yourself. You find the HCF of 180 and 84 by yourself. Then your answer should match with my answer. That's the reason why I am not calculating it here literally. Okay. Because this is an easy chapter. I want you all to work. Okay. Now, using this HCF and LCM, there are few formulae which are very, very useful. First is that for two numbers, the product of HCF and LCM will be equal to the product of those two numbers. Okay. But this condition, it will be valid only for two numbers. If there are three numbers, then this condition will not be valid. Okay. So, HCF into LCM will be equal to product of the two numbers. For example, if you have a question like this. Given HCF 306, 657 is equal to 9. Find the LCM. The two numbers are 306 and 657. We know that HCF into LCM is equal to product of the numbers. With this, I can easily find LCM, right? LCM will be equal to the product of the numbers by HCF. That is 9. I can get LCM easily. Okay. You can use, this is actually short trick to find the LCM. When you have HCF, you can find LCM. When you have LCM, you can find HCF. Or if you have both, you can find the product of the two numbers. Okay. This was all for whole numbers, right? Now we can do HCF and LCM for fractions also. For that also we have few formulas. Two formulas we have. For HCF of fractions, you do HCF of numerator by LCM of denominator. And for LCM of fractions, you do LCM of numerator divided by HCF of denominator. For example, if you have a question like this, find the HCF and LCM of 4 1 by 2, 6 by 2, 10 1 by 2. First what you do, what all the mixed fractions are, they'll convert them to improper fractions. Okay. All the time, whenever you come across fractions, remember that if they are proper fractions, no problem. If they are mixed fractions, convert them into improper fractions. Then this is how you can convert them. Then you find the HCF. HCF of fractions is equals to HCF of numerator. What all numbers are there in the numerator after converting into mixed fractions? 9 is there, 6 is there, and 6 is not there. 9 is there, 3 is there, and 21 is there. And in denominator we have 2, 1, 2. So that you can write here. This will give you HCF. Same way do it for LCM also. LCM of numerator upon HCF of denominator. You have to find the HCF. Separately you find HCF of 9, 3, 21. Separately find the LCM of 2, 1, 2. Then again you divide them. Okay. Now you know how to find HCF and LCM, right? So you try to find out in your book and then you let me know in the comment section whether you are getting the same answers or no. Okay. Actually, one question, same type of question was asked in 2015 HSTR question paper. The LCM of 2 by 5, 6 by 25 and 8 by 35 is. There also I used the same formula. LCM of fraction is equals to LCM of numerator upon HCF of denominator. Then I solved this sum. Here I also showed you how to find the LCM and HCF. Okay. Next, this type of a question also may be asked. Find the least number which is exactly divisible by 12, 15 and 20. Whenever you get this word least, LCM should come in your mind. Least number means they are talking about LCM. I want you all to calculate LCM for 12, 15 and 20 and let me know the right answer in the comment section. The right answer will be among these 4 options. Okay. So I am waiting for your comments. I will not solve this sum here. I will move on. Next question. Find the largest number of 4 digits divisible by 12, 15 and 18. Actually, this time I am expecting this type of a question. See, the question is you have to find the largest number of 4 digits which are divisible by 12, 15 and 18. So, how you find the answer for this? First, you do LCM of 12, 15 and 18. Why I am telling you to do LCM? Because any largest number which is required here, that largest number, it must be divisible by the LCM, right? It must be divisible by the LCM of the numbers given in the question. Once you get the LCM, now you divide any number which is a largest number with 4 digits. Which is that number? The largest number with 4 digits. It should be 999, right? If I take 10,000, then it will be 5 digits. So, 1 less than that will be 999, 9,999. Now, you divide this 9999 by 180. Then you get one remainder. That will be 99. Now, your required largest number will be 9,999 minus the remainder 99. Okay. So, your right answer will be 9,900. Option A should be the right answer. So, you can practice this type of sums. This time I am expecting this type of a question only. Because already they have asked one type of question, right? This type of question they have not asked in 2012 also and 2015 also. So, this time they may ask this type of a question. Okay. Next question. HCF of 2 numbers is 13. If these 2 numbers are in the ratio 15:11, then the numbers are. Here they have given you HCF and they have given you the ratio of those 2 numbers. Let those 2 numbers be 15x and 11x because they are telling about ratio, right? Now you can multiply 15 with 13, you get one number. Multiply 11 with 13, you get another number. Because product of 2 numbers is equals to product of the HCF and LCM, right? So you will get these 2 numbers. So here option C should be the right answer. Okay. Next question. If the product and HCF of 2 numbers are 4107 and 37 respectively, then find the greater number. Here you have to find the greater number and they have given you the product of 2 numbers and HCF of 2 numbers. The product of 2 numbers is 4107 and HCF is 37. They have not given you LCM. You should find the LCM. Once you find the LCM, that will be your greatest number. Okay. Here it will be 4107 upon 37. That will give you 111. Option A will be the right answer. Next question. They can ask you this type of a question also. The traffic lights question. Remember they asked you one traffic lights question in 2015 also, right? So the question is the traffic lights at 3 different road crossings change after every 40 seconds, 72 seconds and 108 seconds respectively. If they all change simultaneously at 520 hours, then find the time at which they will change simultaneously. What you do, what we have done in that class, while solving the 2015 question paper, we have taken the LCM, right? Take the LCM. Take the LCM of 40, 72 and 108. If you take the LCM, you will get 1080. Now convert this 1080 seconds into minutes. It will give you 18 minutes. You have to add this 18 minutes to the 20 minutes because after 5 hours there are 20 more minutes, right? You add this 18 minutes to the 20 minutes. Your answer will be 5 hours 38 minutes. Option C will be the right answer. Now let's talk about square and square root table. This squares means how many times you multiply? 2 times, right? You multiply 1 2 times, it will be 1. You multiply 2 2 times, it will be 4. You multiply 3 3 times, it will be 9. You multiply 13 2 times, it will be 169. You multiply 15 2 times, it will be 225. Okay. You multiply 25 2 times, 25 into 25, it will be 625. So as of now, I feel that you should remember the squares of numbers from 1 to 30. You please by heart. Many of you must be knowing at least till 15. If you don't know, please by heart. If you don't know more than 15 also, you by heart till 30, okay? So these are your square numbers. Once you know the square numbers, you can easily find the square roots also, right? See, 16 square is 256. You have to find the square root of 256. Once you know the squares, you can easily find the square roots also, right? See, 16 square is 256. If you have to find the square root of 256, you will know that it is 16, right? So you better by heart this table. I am giving it here. Either you take screenshot or you write it down in your book right now by pausing the video. You better learn this, okay? In case if you are getting a number which is other than these numbers, then how to find the square root? For example, I am taking a perfect square here to make you all understand. You can do this with the other numbers also. If you want to find the square root of 144, it is an even number, right? So start taking the LCM with a small number. So start taking LCM with a even number. Small number, the even small number, that is 2, right? Go on doing. Whenever you get an odd number, try with 3. Okay? Go on doing till 1. Then again you multiply those numbers and you see how many times the numbers are coming. If their numbers are coming square times, then you write as 2 square. Okay? See here, you are getting 2 4 times, right? So you write 2 square into 2 square and you are getting 3 2 times. So 3 square. So that 12 square will give you 144. So the square root of 144 will be 12. Okay? Same thing you can do with perfect cubes and cube roots also. You by heart the cubes, the perfect cubes and cube roots. Okay. And then it will be easy for you to solve the numericals also. Wherever you are getting square roots or cube roots, you can easily solve them. Okay. Now how to find the cube root if that number is not a perfect cube? This is how you can do. I am taking again a perfect cube root only because it will be easy for you all to relate, right? So I am taking 8000. Now start doing with LCM with 2, the even number, the smallest number. Then again go on do till you get a odd number. Once you get a odd number, try with 3. It is not divisible by 3, right? 125 is not divisible by 3. So start with 5. Okay. Once all are done, now you should not look for the squares. Now you should look for the triplets. Triplet means 3 times of numbers. 2 3 times will be there. Again 2 3 times will be there. 5 3 times it will be there. Take the single numbers and then you multiply. That will give you the cube root of this number. Okay. In case you are getting a number which is a decimal number, then what you do? If that whole number is there, you will find the cube root easily. If it is a decimal number, what you do? See, for example, if I am getting here 15.625, what I do, I remove the decimal from the numerator, I put the zeros in the denominator. This is how you convert the decimal number into fraction, right? So I will write it as 15625 upon 1000 because 3 digits, after 3 digits, I have a decimal point from the right hand side. So I will write 3 zeros below, 1000 it will be. Now individually I will take the cube root. I will see that 15,625 means 5 is there, right? I will take the LCM with 5 and 1000 means it is 0. It is even number, right? I will take the LCM with 2 and then we'll end it with 5. Then I will see the cube root. I will remove those. What all the see 5 is 6 times, right? So the cube root will become 2. It will be 5 into 5. Here 2 cube is there and 5 cube is there. So I will remove that cube root with the cube. I will have 2 into 5. So 25 and 10 I have. Now I will divide this 25 and 10. I will get 2.5. This will be the solution for this cube root of 15.625. Okay. I am just giving you a gist. I am giving you one small example so that you can recall and then work on these. Okay. Now I have 2 questions which may be asked in your KREIS examination. These are next level questions, but they are from number system only. First question is, player 1 and player 2 are running around a circular field. Player 1 takes 16 minutes to take one round, while player 2 completes the round in 20 minutes. If both start simultaneously and go in the same direction, after how much time they will meet at the starting point? See, you read the question 2-3 times if you don't understand. Okay, here what they are telling that there are two players who are running around the circular field. Player 1 is taking 16 minutes to take one round, and the second player is taking 20 minutes to complete that round. Okay, now they are asking that if they both are starting at the same time and in the same direction, how much time they will meet at the starting point? The answer will be your LCM. Time taken by the players to meet again will be LCM of 16 and 20. Now if you take the LCM, you will get it as 80. Now both these players, they will meet at the starting point after 80 minutes. Okay. If you know the concept, then it is a very easy question. But if you don't know the concept, you will waste a lot of time in the examination. So I am making you to solve this type of numericals also. Okay, next question is, there are 56 students in section A and 58 students in section B of a class in a school. Find the minimum number of books required for their class library so that they can be distributed equally among the students of section A or section B. Here also you have to do LCM. First, clearly the number of books that are to be equally distributed among section A or section B, it should be the LCM. Means they should be the multiples of 56 and 58. Now find the LCM. 56 and 58, either you take the LCM separately or you take it together. You will get the same answer. It will be 1624. Now these 1624 books, they are required in that library to distribute in those students among section A or section B. Okay. So this is all about your chapter number system. Believe me, if you attend this class carefully and if you work out each and every numerical, then you are good with this chapter. You can move ahead for the next chapter. Okay. I hope that this class helps you, and if you have any doubt, you can let me know in the comment section. And also I am looking forward to your feedback. Please let me know how is my teaching. If you are like my teaching, whether I am slow or fast or whatever problem you have, you can let me know. And also please do like, share and subscribe to my channel. And that's it. Thank you. All the best. Bye.